Welcome to all of you on my channel Physics Hub. Today is 6th December 2018 Thursday, and here I am with a new set video. As you know that we upload a set video on every Sunday, and it usually consists of 10 solved problems on different topics of physics. But we could not upload the set video on last Sunday, so we are presenting it to you today. We generally upload the question paper few days before the day we upload the solution on YouTube, so that you can try to solve the questions and match your answers when the solutions are uploaded. One thing, whenever we upload a video, we distribute it into different playlists, relatable playlist. So go through the playlist and you will be able to get videos as per your choice, and keep a track of our community post. Also, it will help you to make your base strong. Now only 9 days are left for your CSIR NET exam, so it is quite obvious that your preparation is at peak. You all are solving questions, reading different topics. One thing I would like to tell you here, that keep a quality time for revision. Read, practice, revise, and try to give at least 4 full-length tests in these 9 days. And regarding short notes, prepare it by yourself. No one can give you the best short note for you. It can be prepared only by you. Anyways, I will try to provide you short notes on this channel as much as possible. I will start uploading them very soon. Now without any further delay, let's start today's set video. So as you can see, this set contains questions from classical mechanics. The first question reads, small block B of mass m is placed on an inclined plane P. This is the inclined plane P, which makes an angle theta with the horizontal cart C, on which P is rigidly fixed. The coefficient of friction between the block B and the plane P is mu. When the cart stays stationary, the block slides down. If the cart C is moving in the horizontal direction with acceleration A, the minimum value of A for which the block remains static on the plane is. So this is a very good question, and this question came in TFR last year. So let's solve this problem. So this is the free body diagram. If you draw this free body diagram, you see that the block is at this point, so the frictional force will be acting in this direction because it is given a force on this direction, so the frictional force will act in opposite direction. Okay, so in this direction it is acting tangentially, and m is there, so mass is acting downward. My drawing is not so proper. Okay, so mg should act vertically downward. Now mg will have two components, mg cos theta and mg sin theta. If this angle is theta, then this angle will also be theta. 90 degree minus theta means it will be mg sin theta, the perpendicular component of mg. And ma will be in this direction because force is acting in this direction, so equal and opposite force will be acting in this direction. Now we have to see which are the forces balancing each other. Now according to the question, the block is to be in in static equilibrium, means the block should be at rest. Now for the block to remain static on the plane, the various components of forces will be equal. So N, this upward force, should be equals to the downward force. Now what is the total downward force? The contribution toward the downward force comes from this mg cos theta and ms sin theta, because if this angle is theta, then its angle is 90 degree minus theta, so ms sin theta. So n equals to ms sin theta plus mg cos theta, and for this the frictional force plus this one component will also come in this direction, ma cos theta, will be equals to mg sin theta. Now what you do, now if, as you know, F equals to mu into n is the normal reaction, so mu into the value of n can be got from this equation. So you just replace the values and take a common, and you will get this answer. We have divided the numerator and denominator by cos theta, so you will get a equals to g into tan theta minus mu by mu tan theta plus 1. and if you observe, it is matching with option 1. So option 1 is the correct option. Now coming to question number 2, a particle of mass m moving in one dimension x is subjected to the Lagrangian L equals to half m into x dot minus lambda x whole square, where lambda is a real constant. If it starts at the origin at t equals to 0, its motion corresponds to equation. Now this is a very trivial question. These questions requires the knowledge on classical mechanics as well as mathematical physics. So when we are given Lagrangian, we can easily find out the equation of motion using this Euler-Lagrange equation, ddt of del L del x dot minus del L del x equals to 0. Now what we get from this by using this equation of motion, we see that x double dot minus del lambda square x equal to 0. Now the answers are given in terms of x, so this is a second order differential equation, so we have to solve it, then only we can get this equation of motion in terms of x. So this is a very easy differential equation. So m square minus lambda square equal to 0, m equal to plus minus lambda. So the solution is given by c1 e to the power m1 x plus c2 e to the power m2 x. So m1 and m2 is given to be plus minus lambda. So we have just replaced m1 m2 by lambda, and the variable independent variable is t here, so it is replaced by t. Now c1 and c2, two unknown constants, so we have to remove them, but only one condition is given. It is start at the origin t equals to 0, but look at the option, there is one unknown, so in total we have to find out only one unknown. So one boundary condition or one initial condition is enough to eliminate one constant. So we just applied the initial condition given at t equals to 0, x equal to 0. So we got c1 equals to minus c2, and as a result of that we see a sine hyperbolic lambda t, and it is matching with option 4. Now moving on, question number 3, the Hamiltonian of a dynamical system is equal to its total energy provided that its Lagrangian. Now this is a theoretical question, you should know it while reading the topic Lagrangian Hamiltonian. So these are the equation of motion, pj dot equals to minus del h by del qj, qj dot equals to del h by del pj. This is very confusing. I usually get confused when to use the plus sign or minus sign, but when you will get pj dot, it will be minus del h by del qj, and qj dot equals to del h by del pj, and del h del t equals to minus del L by del t. Now as you can see, if L does not contain any term related to time, means if L is independent of time, then this term becomes 0, and if del h by del t equals to 0, then h is conserved. Okay, so when Lagrangian is not explicit function of time, then h is equivalent to the total energy of the system, which will remain constant during the motion. So Hamiltonian will be equals to the total energy if the Lagrangian has no explicit time dependence. So option 2 is the correct option. Now coming to question number 4, if the Lagrangian of a dynamical system in 2 dimensions is L equals to half m x dot square plus m x dot y dot, then its Hamiltonian is. This is also a typical question for net aspirant. So Lagrangian, as you know that Lagrangian is a function of the coordinate and velocity, means q and q dot. So as you can see, it is written in terms of x dot y dot, so x and x dot. But to find Hamiltonian, and as you know, Hamiltonian is a function of position and momentum, not a function of velocity. So in the Hamiltonian term, there should not be any velocity related term. Now px equals to del L del x dot equal to mx dot plus my dot, and pi equals to del L del y dot equal to mx dot. Now we cannot keep x dot y dot because Hamiltonian is not function of this dot thing, so we have to replace them. So what we did, we just tried to write x dot and y dot in terms of px and py. Okay, now the Hamiltonian formula is sum over pj qj dot minus del L Lagrangian, which is a function of qj and qj dot. So we just expanded the sum px x dot plus py y dot minus half m x dot. In place of x dot we just replace py by m, and in place of this x dot we replaced py by m. Then in place of y dot we just replace this. Okay, now after calculating, this calculation is simple. So px py by m minus py square by 2m, and we see that it has matched with option 3. So option 3 is the correct option. Look, before solving the question, you just have a look at the option so that you can solve it in minimum time. Now moving to question number 5. A particle of unit mass moves in the xy plane in such a way that x dot t equals to yt and y dot t equals to xt. We can conclude that it is in a conservative force field which can be derived from the potential. So okay, so this is given x dot t equals to yt and y dot t equals to minus xt. Now for a conservative force field F, it can be derived from a scalar potential V, then F equals to minus del grad V. Now F equals to m into x double dot means the mass into acceleration I cap plus mass into acceleration j cap. This is along y axis, this is along x axis. Now they have told that we have to take unit mass, so we have just put m equals to 1 here, so x double dot I cap plus y double dot j cap. Okay, now how to find out x dot and y double dot? X dot is given, so x double dot means y dot t, and y dot t equal to minus xt, so x double dot equal to minus xt. Similarly, y double dot t equals to minus yt. Now F equals to minus grad V, so minus del Vx by del x I cap minus del Vy by del I j cap equals to minus x I cap minus y j cap. So we just take derivative with respect to x. So derivative just equate the two things on the on both sides. So del v del x, del vx by del x equal to x, so vx equal to x square by 2 and vy equals to y square by 2. Therefore v equals to half into x square plus y square. So it is matching with option 1. Option 1 is the correct option. Moving to question number 6. A particle of mass m moves in the one-dimensional potential v of x equal to a by 3x cube plus beta by 4 x to the power 4, where alpha beta is greater than 0. One of the equilibrium points is x equal to 0. The angular frequency of small oscillations about the other equilibrium point is. Okay, so the potential is given like this. Therefore dv dx equal to alpha x square plus beta x cube. Now for equilibrium we know that dv dx equal to 0, so we get 2 and 3 equilibrium points. Now they have told that they want us to find the angular frequency about other equilibrium points, means other than 0. So we got 0 0, so other one is minus alpha beta. Okay, so as you can see it is coming 0, that's why they have excluded it. But at if you check the double derivative at x equal to minus alpha by beta, we get alpha square by beta, and both alpha and beta are positive, so the result is positive. And when the double derivative is positive means the this point corresponds to minima. So it's a stable point. The angular frequency of small oscillation about x equal to minus alpha by beta is root over d square by dx square x equal to minus alpha by beta by m. Look, this m is under root, okay, don't get confused. So alpha square by beta by m, so alpha by root over beta m, and it is matching with option 2. Option 2 is the correct option. Moving on, question number 7. Consider 3 inertial frames of reference A, B and C. The frame of B moves with velocity c by 2 with respect to A and C moves with a velocity c by 10 with respect to B in the same direction. The velocity of C as measured in A is. So I have shown you the situation. 3 frames are there. Let's take it S. It's S prime, and it is moving with velocity u prime with respect to this S prime. The velocity of B frame with respect to A is V equals to C by 2. The velocity of C frame with respect to B frame is u prime equals to C by 10. Therefore, the velocity of C frames with respect to A frame is u prime plus V by 1 plus u prime V by C square. If you calculate it, you will get 4 by 7 C. So this is basically the Einstein velocity addition formula, and using that you can easily get 4 by 7 into C. So option 2 is the correct option. Moving to question number 8. A particle moves in one dimension in the potential V equals to half k of t x square, where k of t is a time dependent parameter. Then ddt of average of V, the rate of change of expectation value of V of the potential energy is, sorry, that is not average value, that is expectation value. So this is a midway question between classical mechanics and quantum mechanics still. So k is a time dependent parameter. Now as you know, ddt of expectation value of B equals to 1 by I h cut expectation value of this VH plus del V del T. So this kind of formula you have seen in quantum mechanics, in Schrödinger picture, Heisenberg picture, etc, etc. You can look at those topics. Those topics are very important for this CSIR net now, momentum and coordinate representations. So you can check that out. Okay, so what we did, we have replaced the value of h to be p square by 2m plus v, and del v del t means half x square. Now x is not a function of time, so it came outside, but k is of a time dependent parameter, so we have to take the derivative with respect to t. So now we had to open this Poisson bracket. How to do that I have shown you in great detail, so you can easily get it. So x square means x into x, so the first x is come on this side and another x goes this side. Okay, in the next section we did p into p, so x, the first p comes here and the next p will go there. Similar thing is happening here, and as a result you will get this. So you just replace the value of Poisson bracket of x square p square in this expression, and what you discover that it is matching, and it is what you discover that it is equal to this, and it is matching with option 1. So option 1 is the correct option. Okay, so if you don't understand any part of the calculation, you can comment down below. I will try my best to clarify those points. Don't worry, I'm very cooperative. Let Q and P be the canonical coordinate and momentum of a dynamical system. Which of the following transformations is canonical? Now one thing you know that about canonical transformation, that the Poisson bracket should be equals to 1. Now we'll just do that. We'll test whether the Poisson bracket is 1 for them. So for the beginning, take the case of A. So Q1 equals to 1 by root 2 Q square, and P1 equals to 1 by root 2 P square. So Q1 P1 with respect to QP, this is the canonical transformation of this case A. So if you do that, you get 2PQ, which is not equals to 1, so transformation is not canonical. But for B, we see that the transformation, the Poisson bracket is equals to 1, so the transformation B is canonical. So A is not canonical, but B is canonical, so it is matching with option 4. So option 4 is the correct option. Finally, question number 10. A rod of length L carries a total charge Q distributed uniformly. If this is observed in a frame moving with a speed v along the rod, the charge per unit length as measured by the moving observer is. Now as you know, charge is invariant quantity, but charge per unit length is not invariant because the length contracts if it moves with relativistic velocity. The charge per unit length as measured by the moving observer is q by L prime. L prime is the changed length due to the motion, relativistic motion along some axis. So L prime equals to L by gamma, where gamma is root of 1 by root over minus 1 by root over 1 minus v square by c square. So we just replace the value of gamma here, so we'll get q by L into root over 1 minus v square by c square, and it is matching with option 3. So option 3 is the correct option, and this is the end. So I have tried my best to provide the solutions in great detail. Irrespective of this, if you have any doubts or confusion, you can comment down below. I'll try my best to clarify them, and any kind of suggestions are always welcome. So this is all for today, guys. If you find this video helpful, please give it a thumbs up, make the like button below, and if you are a new visitor of this channel, please subscribe the channel and press the bell icon so that you never miss any update. Keep sharing and keep loving in this way, and what I say at the end, thanks for watching.